Hello, everyone, and thank you for joining us today on the Dairy Signal. We're going to be diving into all things weather here momentarily, but before we do so, it's not a Dairy Signal without a little bit of today in history. And today we are headed to 1862 as it was the abolition of slavery in Washington, D.C. And if you were listening yesterday, you know that it was an unfortunate day in history. In 1865, where Abraham Lincoln ultimately passed away due to the gunshot wound he experienced the day before. But it was on this day in 1862 that he signed 3 years prior to his death. He signed the District of Columbia Compensated Emancipation Act that ultimately abolished slavery in Washington, D.C. So a little bit ahead of its time for where the rest of the country was, but only a few years later did that happen for the rest of the country. So with all of that being said, though, I know we've got a lot to get to this afternoon as we dive into some really great information about the weather, especially as we know it is spring and we are either in those fields or really itching to get into our fields. And joining us this afternoon to give us kind of an outlook of what we can expect or maybe things to be keeping an eye on is Daryl Richardson, who is NDON Director and State Climatologist for North Dakota. So thank you, Daryl, for joining us again. It's a pleasure to have you back. And I know that we don't have a whole heck of a lot of time to do introductions because we want to get into the meat and potatoes of it. But if you would take a second to remind our audience just a little bit about who you are and a little bit about how you got to be where you are today.
Well, I grew up in a small town in southern Minnesota. Always been fascinated with weather ever since I was about probably 4 or 5 years old from my early memory. Originally went to college, to be honest, to be a science educator. But I was the end of the baby boomers, and when I got out of college, there were no teaching jobs anywhere at all. So I went into graduate school, still always loved weather. And so in turn, I did work through the geography department, was their first graduate actual with emphasis in atmospheric sciences at what is now referenced as Minnesota State University, Mankato. When I went, there was just Mankato State in southern Minnesota. I also have an MBA, a Master's of Business Administration. I spent a large part of my career in broadcasting. And now for the past little bit more than a decade, I've been at North Dakota State University, which is based in Fargo, North Dakota. I'm the director of the North Dakota Agricultural Weather Network, which I'll explain briefly here in a second. And it's been about a year ago now that I was also designated the state climatologist for North Dakota. So a couple of jobs. I also teach weather and climate courses here at North Dakota as well. So that's at least a brief summary of who's who in Daryl Richardson. I don't know. And
Well,
speaking of which,
Daryl,
I'm going to go back away a second here. I know we're kind of live here, but I just wanted to turn off my volume on a different computer. So every time I get an email, you don't all I deal with that. So on that note, I will go in if it's okay and then kind of a briefly explain and on to folks, because really no matter what state you're listening from, most states now have a weather network, and these are usually referenced as a mesonet. So I'll spell that out, a mesonet. And a mesonet is really, meso is Greek for middle, and then net is a network. So it's kind of like in meteorology, there's mesoscale weather. Say a cluster of severe weather would be a mesoscale weather event. So we're really trying to dictate where that occurs. And this is the North Dakota Agricultural Weather Network. And of course, ND stands for North Dakota, of course. But we're not only in North Dakota, we're a little bit off into the northeast corner of Montana. And you notice I am very widespread in Minnesota. And really, you notice on the screen right there, the Minnesota Department of Ag, we're working on a project in Minnesota. And really from about this right here, skip to Twin Cities, all of this area in Minnesota, so the southern and western part, is we have monies to install a whole bunch more weather stations. So we will be doing that in the upcoming year. Matter of fact, we're going to install another 20 stations in Minnesota during the upcoming summer of 2025, starting in just 2 weeks. Plus, we'll do a lot of work in North Dakota as well. So that's a mesonet. Again, most states have one. And I'll go show you a little bit of the data coming up that might help you with spring planting in particular. But, it's not only NDON data here. I mean, this is weather data in general. I mean, it can be used as a weather risk management. I always consider it a weather risk management tool. And really what we're doing is we're using weather data to predict the future. With Endon, we have tools that we can forecast when a certain insect's going to come out. And usually we get it within 24 hours or 48 hours at the most. So it's preparation, pre-spraying pesticides, for example. We also know when crop diseases are going to very likely form, you can get out there with your fungicide, and doing this, or it's a year where the disease just isn't going to form. So if you spray, of course, there's a return on that investment. And if you don't have to spray, well, you don't have any inputs. You're saving even more money. And so all of this brings a value proposition. In some ways, that's a fancy way of saying a return on your investment. And Endon and most Mesonets work way beyond agriculture. We're one of the few Mesonets that actually have an A in our name, standing for agriculture. But again, we do a lot of work beyond that. If you're ever curious about North Dakota or Minnesota weather, these are two websites that you can go to. They're similar, but a little bit different. Endon.info is mobile compliant. And this one up here, we're in the process of updating that. So again, if you're in a state, look it up. If you've never used Mesonet data, it's very, very useful and very, very handy. And if you're curious, this is what one of our weather stations actually looks like from a drone perspective. And this image, by the way, this was spring wheat, and this is spring wheat on either side. That usually doesn't happen, but this year, last year when this photo was taken, it actually worked out that way. Now, when I was on here the last time, we were talking about winter, and I had said, I'm always very honest in my talks. I always tell people previous forecasts, I said, the winter looks really average to me for a lot of spots, especially in the north central part of the United States, from the Great Lakes to the Great Plains, from the Canadian border, down to, say, Missouri. And this is actually what happened this past winter. These are temperature anomalies, and winter by definition is December 1st through February 28th, or on leap years, February 29th. And you'll notice there's a lot of white, but even some of the blues, usually anything within 1 degree of average is definitely average. And this map really narrows it down. But you look at this, and it's hard to say anything, but it was pretty close to average for a lot of folks. Maybe a smidge above, a smidge below, but you're never exactly at the average. And then precipitation-wise, you can go, geez, Daryl, a little drier than average. This, I would say, was drier than average for most folks. But here's the thing about winter. You get more rain in June than you do in winter by times 2 usually. So we really don't average a lot of winter precipitation. We think of it as a lot because we get a foot of snow, that's a lot of work involved in that. But a lot of times that only contains 3/4 of an inch of snow. And plus, how many times do we really get a foot? Most of the time it's lighter amounts. But granted, March is technically a spring month in climate circles that I deal with. But notice we got a lot of precipitation in March. So really, if you add this into it, it was a pretty average winter, a little bit above, a little bit below. So I was pretty happy with that general forecast that I had last winter. Now, because of the precipitation in March, what we had last fall, these are current soil moisture anomalies. And you'll notice there's a lot of green on here. Most areas are not necessarily suffering from dry soils. In my winter talks that I've given around the region and even in the United States, I mentioned it looks very promising for planting, that the seed will germinate, we will get going, and there's moisture there to get the germination process going. The thing is, obviously, it needs to rain again. And that's some of the things that we're going to talk about. But really just looking at soil moisture, yeah, there's some dry spots, but overall, things are looking pretty good in that regards as of today. Here's the drought monitor. You notice most of the dry conditions are really more in the high plains, so really say the Missouri River and westward in many conditions. There are some dry spots in Iowa, some dry spots in Minnesota, a little bit in Wisconsin, but really not very widespread. And again, the soil moisture page that I already showed you was a strong indication that, again, things are not looking all that bad at the moment. To get started with planting, you really, in many ways, you can plant small grains, wheat, and temperatures that are out there right now. But really the core crops of soybeans and corn, the magic number for most people is to wait till the soil temperatures at around 4 inches or 3 or 4 inches, but it's usually measured at 4, is to get to 50 degrees. Now, this map is the Wisconsin Mesonet. Okay, so you look up Wisconsin WeatherNet. It's called something besides the Wisconsin WeatherNet, but these are their soil temperatures. And you notice, especially in the southern part here, where a lot of the key crops are grown, we're getting there. It's still in the low 40s. We are behind, say, spring planting. It's still early by a couple percentage points nationally. Well, one of the reasons is truthfully is the soil temperatures are not warming up very quickly this spring because we keep flip-flopping. We're warm for a few days and then we cool back down again. And we need some consistency, and it doesn't look like we're going to get this. Now, this is Iowa. Iowa doesn't have a traditional weather network. A lot of this is on here is estimates on computer guidance. The red numbers are actual temperatures, but you'll notice this is probably close, although it's not real numbers. It's in that 45 to 50 range. And again, not much, corn in particular has been planted in Iowa. Now, this is Indiana Mesonet, and mapping is a little bit different, but you'll notice the numbers are mainly the 30s or low 40s in the north. You get down to the south even, most of these numbers are still in the 40s. So really not too many people are at 50 degrees. And where I live, well, I live in a very cold climate in comparison to most of you listening, 30s and 40s. Again, a lot of wheat has been planted in my region, but not much else is. And if I zoom into my area in Minnesota, you'll notice even southern Minnesota, which is great corn and soybean country down there, it's only around 40 degrees today. And when you look at soil temperatures, if you look at them in the peak heating of the day, it's 4 o'clock, it says 48 degrees. It's not a good time to check soil temperatures because that seed is going to suffer then and dry. It's a lot of times it's in the morning, or take the daily average of what that soil actually is. So again, we're running a little cool, it will happen. So again, average May rain. If you look at this, for a lot of areas here, where many of you are probably listening from, average May rain. May is the beginning of what I like to describe as the rainy season. If you ever watch a TV show about Africa, and you'll notice, those poor elephants, they have no water and they're looking for that last little puddle. Well, that's because they have very distinct wet and dry seasons. Here in the United States, most of us get moisture all year round. And so when you do climate classification, it's considered a year-round precipitation. But again, we don't get a lot of it in the winter, but we get some. It's not a perfectly dry season, but we get into May. Most of you always know this. Poof, all of a sudden patterns change. And May and June for most folks, in the core of the United States, the core growing areas, it's May and June are the wettest month. And so if you don't get, planting a lot of times is delayed and you just have to wait around the rain. But in the end, the rain's good. We have to wait. But I wanted to show you that because this is trends in May. This century, notice I started in 2000 on both of these, 2001. Decades and centuries begin at 1. For all of you who celebrated on 2000 of the new millennium, technically did it a year early. That's okay. When I celebrated it in real life, only 3 of us showed up, so everyone partied a year before me. But joking aside, you'll notice this is just trends in May. Because a lot of times these trends and weather patterns last 20, 30 years. And those of you old enough to remember that, well, I remember this and I remember this. When my dad was still alive, I loved hearing the stories. This decade was this. I remember back and forth. So I like showing trends, and you'll notice the trend is kind of a mixture of most areas. May has trended warmer than average slightly this century. Not every May. This is a trend overall. And it really depends where you are, wet or dry. But average, but these are the trends. And I like using these because there's some usefulness when you're doing long-term forecasting by looking at the trends. And everything, of course, I talk about is averages. And if you were with me the last time I was on with you all, I reminded you of this. What is average is the past 30 years in whole decades. So again, right now, everything you hear, if you're watching a TV person, an ag meteorologist, your best friend down the road a couple of miles, we're below average or above average. That average is based on 1991 to 2020. And so we're kind of in the beginning still. We're getting towards the middle of that. But I showed you a bunch of these the last time, so I'm not going to repeat it. But this is just Madison, Wisconsin, precip from average. And Madison, Wisconsin has data 1869, and I do not have 2020's data on here. A lot of it's below average. But if you think of an average, it's an average. The median is the middle number. But the average, if you look at this during that entire time frame, you notice half the lines are green above average, half of them are yellow, orange, whatever you want to call that, gold, below average, which is what you would expect, right? And notice how many short lines are on here. Not many. And if you're watching, no matter what state you're on, this graphic would look about very similar to this, okay? Notice many of you, your ancestors may have come on in the 1870s, 1880s, grabbed their 160 acres of land. Notice it was pretty wet back then. And then we're pretty wet right now. So the wetness now is not unusual. We just, we don't have a lot of records. But I want to take you and show you this. So this is based on the long-term average. I took every year from 1869 to 2020 and made an average. Half of them are above it, half of them are below it. Well, if we use the current 30-year average from 1991 to 2020, you have to remember the 1990s were crazy wet, especially in southern Minnesota, southern Wisconsin, Iowa, and Illinois was really wet a lot of years in the 90s, and it skewed our average up. So right now, this is using the current average from 1991 to 2020. Do you notice many years above average? Not really. So here's the thing. I hear it all the time because I do a lot of ag forecasting. Daryl, I had a really good crop this year, considering I was below average. And I always, sometimes it depends if I know the person well, I will like to say, well, if you had this amount of rain in 2020 when we were using the old average was from 1981 to 2010. We didn't switch until 2021. Remember, we replaced the drought years of the 80s with not so many drought years in the teens. So here's the thing. Only 25% of all years in Madison, and this is true in Indianapolis, Columbus, Springfield, Des Moines, Twin Cities, Bismarck, North Dakota, and Pierre, South Dakota. That's all the state capitals I just picked out, is approximately the same way. And so again, if you're 80% of normal, that's dry, right? I wouldn't argue with you, but it would have been average 5 years ago. So when you plan the markets, remember that last year I had all these calls. Geez, Daryl, Iowa is really below average this year. How do you think it's going to impact the corn crop? Well, you may know this. Iowa and Illinois had really good corn crops last year, and they were below average. Always remember that. I use the average because I kind of have to. I have to match everyone else. But I always like to remind people of that fact. So this was last summer, close to average temperatures last year, and kind of close to average precipitation. Although, I'll do it green too, that area right through there was pretty wet in June, with one thunderstorm complex dropped 10 plus inches of rain for some folks. Otherwise, the summer was really dry. And that's the other thing. You can have a wet summer and still be dry because one storm skews the average. And a lot of times that all goes where? Into the rivers, and it goes away. It's not there for you to use. It's not like you can save it and spread it out through the course of the year. And so that's just the past. Let's look at the future here quick. So this is a quote I love to use. It has nothing to do with weather, deal more with politics. But Mark Twain, Samuel Clemens, history does not repeat itself, but it does rhyme. All right? I'm not going to argue with that. If you think of politics, this is very, very true. Goofy wars that we fight in sometimes, same one over and over again. All right? So I'm going to change it, but we're going to get rid of that. I'm not here to talk about that. I'm here to talk about weather. So I'm going to replace that word with this word. Weather does not repeat itself. No 2 years are the same, but they do rhyme. They're very similar sometimes. That's how, in turn, I forecast long-term weather. My forecast for 2024 last year was really very, very close because it rhymed very, very well. Well, where do you start? I always start in the oceans because it's 70% of the planet. And as we all know, when we make our macaroni and cheese or hot dogs with water, it takes forever to boil the water. and then it takes forever to cool down. So the heat capacity of the planet is not in the atmosphere, it's in the water. So a couple things to look at before I animate this, because this goes all the way back to Christmas, by the way, but I'm going to animate it, is really to take a look at this here, Central Pacific, and look what happens along the west coast of the United States a little bit. So I'm going to take that off and I'm going to run an animation for you all. And you will notice there's blue in the Pacific Ocean. Again, keyword here, anomalies. These are not temperatures. Blue is below average, red is above average. So if you go up here, okay, by the Aleutian Islands or northeast of Japan where it's red and fall off a boat, you're not going to last very long, okay? You fall off a boat down here where it's blue, that's still nice and warm. It's just above and below average. Why does this matter? It matters because, again, the heat capacity of the water. Can you imagine that just the trillions of gallons of water in the equatorial Pacific being warmer or cooler than average impacts things? Because where's all the surface area of the planet? Close to the equator, because we're round. So 0 to 10 degrees north, there's much more surface area than 80 to 90, let alone even 70 to 90 degrees north latitude because we're warm. So this does impact the amount of water vapor that goes in the air. That makes rain, of course. Also, that is evaporation. It's a cooling process. As you know, when you step out of the shower in the morning, it impacts weather flows and patterns around not only North America, the entire planet. Now, this is computer analysis. So here's the thing. El Nino or La Nina. So El Nino is warmer than average equatorial Pacific. La Nina, which we just went through, is colder than average. To be at La Nina, you technically have to be a half a degree Celsius. Think of it as 1 degree Fahrenheit below average. And you'll notice we barely made it. It's like 0.055. But it technically was a La Nina, very short-lived. Mostly we're neutral. So this here, when you look at this area right here, really what the computer models are suggesting is for the rest of this year, we're going to just be in neutral territory, not above or below average. And truth be told, wherever you live, this is true, because wherever you live, we have the same saying. If you don't like the weather today, wait till tomorrow saying, right? Well, that's as true in the Pacific Ocean as well, because it fluctuates a lot. So you might remember a couple winters ago, El Nino, okay, and then this past winter barely made a La Nina. And you can see the temperatures bouncing up and down here from the average. Well, I'm going to take you back to 1950. And remember, this is the average zone through here, okay? Is the Pacific Ocean ever at average? Nope. Very rarely, just like where you live. We're either up here or we're down here. We're never really at the average. So always this past winter, somebody sent me this article from someone about how unusual it was that the El Nino was short-lived, this one right there. And I go, which one isn't short-lived? They all are the same. If you go, I'll circle them in red because these are the warm one. Which one of these did not go up and down real fast? That's very common. If La Nina is when it's cold, that linger a while. And you'll notice, before that El Nino, we were colder than average for 3 years. It was a 3-year La Nina. And so, again, we tend to be up or down, but never near the average. So if we go through this entire year near average, wow, where did that happen in the past? I can kind of see where it bounced a little bit after an El Nino in the late teens. We go in the 70s, it kind of bounced around a little bit, particularly in the 50s. And it really depends where you're listening from on. But for many of you, you had 2 years in a row with not a lot of snow. When was the last time a lot of us went 2 years in a winters in a row without a lot of snow? And again, the farther south you live listening, the more common this is. But for those of us who have a permanent snow cover in the wintertime, which is probably many of you listening, it was in the 1950s, right there. And so it's not a coincidence. And look what happened. It's bouncing around the average back then. And the thing is, these are referenced as analogs. It's a year in the past with similar conditions. So if this happened then, and we have almost identical conditions now, why wouldn't that be our weather this summer? And that's how I base a lot of my long range forecasting on when we go through this. So there's another ocean out there, by the way. It's the Atlantic multi-decadal oscillation. Okay. Keyword here is multi-decadal. Okay. So here is an index of where it is. Okay. This is what it looks like. And if you remember that image I showed you of the current conditions, the Atlantic Ocean was almost completely red. It was above average here. This has been the case for the last 25 years. This is what it looks like when you're below average, which was the 1980s and the early 1990s, and actually the 1970s as well. Okay. So this is indexed. And notice this one, there's been a couple of exceptions, but here's a line of about 2000, 25 years ago. And notice it's all red. If I go back here, it was below average from about 1960 to 2000, 40 years of mostly below average. Multi-decadal oscillation. And the AMO tends to be very consistent where you have above or below average for very long periods of time. So right now, may have noticed that the Atlantic Ocean is really red. That means it's above average. Doesn't mean it's warm. Some of it is, obviously, but it's above average. Way above average. So it's strongly warm, or strongly what we reference as positive. So strongly positive. So if we look at summers in the past, and here's some of the years, if you're curious, summers in the past where the Atlantic Ocean has been warm, way above average. What was the summer weather? Well, this is percentage, by the way. So if we look at this down here, you will notice about 2/3 of those summers were drier than average. They have a dry flavor to them across the northern plains, much of Iowa, northern Illinois, southern Wisconsin. Okay. Remember that. So there's this other thing called the Pacific. This one is decadal oscillation. Okay. Decadal. That means it flip-flops roughly in a decade, 10, 15 years. Okay. So remember that graphic? I said, look at the west coast of the United States here. When the west coast of the United States, and again, if you've ever been to California, Pacific, you know that it's a cold ocean current there. So it's really cold. Okay. So cold current out here, that means the Pacific decadal oscillations in its cold phase, cool phase, which is usually referred to again as negative. Negative is cold, positive, warm. Here is when it's warmer than average, is its positive thing. So let's look at that same chart. This is for the Pacific Ocean, okay? Notice here, so far this decade, it's been cold. In the teens, it was warm. And notice it kind of goes back and forth. It's a little bit more sporadic than the Atlantic Ocean for the last century plus. But still, you can see, oh, this decade's this decade's that. And if you've been in agriculture long enough, and you all pay attention to the weather, that's why I love you. The civilians out there in the cities don't pay much attention to the weather as we do. But the thing is, you might notice, oh yeah, the 1980s was this, the 1990s was this, the 20, and it does oscillate. You're not crazy, no matter what news articles tell you. Okay, that does happen. Your memory is many ways correct, going back and forth. So if we take the PDO and the AMO in Pacific and the Atlantic Ocean, you will notice when they're in certain phases here that they actually, I'm going to go back, when they're in certain phases, you will notice that there's different, and again, the reds are dry years, the blues are wetter years, statistically, not 100%, because the weather doesn't work that way. But there is a relationship between the two that you can use to kind of forecast what the odds are as a summer. So now this is, again, this is percent of years, so this is a statistical thing. Right now, most of the past winter, that PDO, remember the AMO was strongly positive? The PDO is strongly negative. You know, Pacific and Atlantic Ocean, it's like you and your wife, you know, you just kind of fight once in a while back and forth. They're never the same. All right. So anyway, this is right now, the PDO is actually just negative, but I have a feeling it's going to go back to strongly negative. But look at when the PDO is negative, look at all the colors here. it's that greater, it's probably 60, 70% of the summers are drier than average. So the Pacific Ocean in its current phase would give more years than not being drier than average. The Atlantic Ocean in its current phase would bring more years than not that are drier than average. Mother Nature gives us hints. So if we look at the summer of 2025 now, okay, moving forward, so we just came off, now that whole El Nino thing, it goes from El Nino warm, La Nina cold, back and forth. And we showed it to you for the last 75 years since 1950. The technical name for that is ENSO, which stands for El Nino Southern Oscillation. So even though it's in a La Nina, not in the name, it's this Southern Oscillation. And here's the interesting thing again, that letter of the alphabet right there, oscillation. Let's repeat, AMO, Atlantic Multi-Decadal Oscillation. PDO, Pacific Decadal. I can hear you all, wherever you're listening from, oscillation. ENSO, El Nino Southern Oscillation, okay? We just finished a winter with the ENSO being negative, which is a La Nina, and a very weak one, about as weak as you can get and be even qualified for that. So there we go. So what do summers look like historically after we finished? Because there is not going to be a negative ENSO this summer. It's going to be neutral. But this is winters after one, okay? Let's look at this map. Wow, a lot of brown again, depending on your area, especially approximately here, to use a reference, the Mississippi River west tends to be drier than average. And again, well, Daryl, that area is drier than anyway, climatically. Oh yeah, yeah, you're absolutely right. But again, these are based on averages. It's drier than average, okay? And this is based on the current average. So again, I already talked to you about that. But again, you look at this and you're just going, so I've showed you the PDO, generally speaking, on these maps, when it's negative, not every year, because every year is unique. Again, I cannot emphasize enough, the atmosphere is a nonlinear chaotic system. Okay, I've been doing this for 35 years. Trust me. You don't. Anytime you meet a meteorologist that's a little cocky or a little arrogant, don't listen to him, because weather should be very humbling, because we all make it just doesn't work the way you want to sometimes. But again, the AMO in its current phase tends to have, again, really a lot of times just referencing this part of the United States right there, has a tendency, a lot of those areas will be drier than average. The PDO in its current phase tends to have more years than not drier than average. Now we have this coming off this weak La Nina, the summers after those, and there's like 7 examples, 6 of those 7 are below average. And so, which is even a higher percentage in it, but some of these percentages here, you'll say only 15 to 25% are wetter than average. Well, we can flip that around and say, 80% are drier than average. And it's just the software I use always has it above. And so again, I like to use the term flavor. It has a dry flavor associated with this on the map. So we have a negative PDO this past winter. And again, truth be told, much of last summer, fall, and I would equate one of the reasons the fall was so warm and dry for many of us was how strong the PDO was last autumn. But we have a negative PDO, and this past winter we had a negative ENSO. This summer, again, ENSO is just going to be very, very likely neutral, but the PDO will remain negative. I am very convinced of that. And it's just a matter of how strong and how negative it's actually going to be. So if we take these 2 parameters and mix them together and do the statistics on it, there's still a lot of brown on the map, okay? And matter of fact, the brown is more widespread now than it was before. You notice there's pockets out there, and And if you look back, you'll notice, why did this little area get more rain than everyone else? It's a nonlinear, chaotic system. Sometimes even I can't explain it after 35 years of experience, but there are some little pockets that happen to go. But again, look at this, a dry flavor. It's, a lot of this is in that 2/3 range going on. But so far, every map I've shown you has had this tendency to be drier than average. Okay. And truth be told, even the old average, it had a tendency to be drier than the old average, not the new one that we're on. So if you look at temperatures, here's the thing about the software that I use. It was a gift to me, by the way, because software is like, it's in the 5 digits to get the software. And it was a gift. So I cannot adjust the scale. And you'll notice on the temperatures, it's using quarters of a degree. So, but if you look at this, it still leans a little bit, I think most of you realize this. When is the hottest summers or the driest summers? Because you heat up the soil, and if the soils are wet, all of that energy goes into the soil and it has to evaporate that soil moisture. Again, evaporation is a cooling process. When you step out of the shower, yeah, the water was 110, 15, 20 degrees, and you stepped out into a 70-degree room or maybe colder, no doubt. But when you step out of the shower, all that water on your skin starts to evaporate and it cools you down. That's sweat. That's how sweat works. It's a cooling process. So wet soils tend to equate to cooler summers. Dry soils equate to warmer summers. The 1930s, the Dust Bowl years, a lot of that was our own fault. We plowed up everything, didn't have good erosional controls back then. We've learned things since then, but we had all that dust all over the place, which heated up. That's why we got to 115, 18 degrees. Same weather today might be 105. Trust me, that's still hot, but it's a little cooler. But that was the soil and the dryness. So again, to have a summer a little drier than average, no surprise, would be a little bit warmer than average. And it really depends again where you're listening from, because even a half a degree warmer than average means you're going to get approximately, again, this is a product because it's a lot of you, different areas listening, would be anywhere from like 75 to 100 extra growing degree days for corn and soybeans. And for small grains, that would be 200. It's a lot, a half a degree one way or the other. Now, some of you listening farther south, half a degree, you're going to get to where you need to go, probably even in a cool summer. Where I live, they're trying to grow corn now up in southern Canada, along the North Dakota Canadian border. Wow, 1 degree is 150, 170 extra growing degree days. That saves them. If they're cooler than average, it goes to silage. But anyway, I'm just saying, because the growing seasons are so, long enough that, again, even a half degree gives you a lot more growing degree day units. So it can or cannot, depending on where you're listening from, matter to you during the course of the season. Now, if I'm going, I don't see hardly any other like ag meteorologists, forecasters showing you this graphic. But where do crops really grow from? And when I ask people that, they always say water. And I can't deny that. Or growing degree days. I can't really deny that either. But it's really photosynthesis, which starts with the sun. And we've had summers that have been above average, but our crop yields have been down because the fact that above average temperatures occurred at night because it was a very cloudy summer. So the high was 78 and the low was, 65 or 68, depending on where you live. So yeah, that day finished 3 degrees above average because the morning low was 5 degrees above average. But the crops want sunshine in the afternoon. So having more solar radiation anomalies can be a net positive, but it can be a net negative. More sunshine means more evaporation potential, especially before row closure, which takes, of course, a lot longer for, say, soybeans and corn. But no surprise, if you're going to be, say, a little drier than average, that means you're probably going to see less thunderstorms, which means you're going to see more sunshine. So it should not be a big surprise. But my analogy, my analogs that I use in the past would suggest a little bit warmer, drier, and a little sunnier for many, many areas. And of course, these are broad brushed and every spot's different. Some of you listening, you might be the lucky guy in the middle. Everyone else, all those thunderstorms missed, and you get an extra, 5% extra bushels per acre or something, or vice versa. Just the nature of the beast when most of our summer precipitation comes from thunderstorms. Look at all of these O's. I don't think Amber or any of you would be happy with me if I talked another hour about all of these other O's, but there's a lot more oscillation patterns out there, just letting you know. That's what they are. So a lot of alphabet soup on that one. All right. So in the very short term, you may have noticed so far, and I think one of the reasons really probably we're not a lot because we don't not necessarily plant a lot, but the latest statistics are we're a little bit behind average on spring planting. A lot of it is, temperatures aren't quite warm enough, rain, is coming in the wrong times. My goodness, 2 days and we can be 10% above average. It's just the nature of the beast when you're all out there planting. But we've been flip-flopping, can we get 10 days in a row of just nice warm weather? Not this spring. You get 3 days and then it flip-flops to 3 and goes back and forth. So I don't know what term to use. Amber, before we started off the air, was going, I don't know what to use, but this flip-flopping of seeing some warm and periods back and forth probably is going to continue into early May. So there's going to be opportunities in there. The problem is without a consistency, it's hard to really get those soil temperatures just to climb, because if you get 3 days above average and then 3 days below average, yeah, they're still going to climb because our averages climb, of course, rapidly this time of year. So it's still going to get warmer and warmer, but it's hard to get those soil temperatures up there as quickly as we want. But I think at least through very early May, that's going to be the case. So spring, I think, is just going to be a little slower than most of you would want. It doesn't look terrible to me going forward by any stretch of the imagination. It always, of course, in the spring comes down sometimes to the rain. If it occurs at some of you get done planting and then it rains 3 inches. Woohoo, you're happy and then your neighbor had mechanical problems, didn't get it planted, then he gets delayed for 2 weeks. Those are things that everyone's a little bit different on. But as you probably are not going to be surprised by, I gave you a lot of reasons why this summer is going to have a dry flavor on it. Does that mean I guarantee 100% I'm going to bet the house on it? No, it's weather, but statistically, that's the case. And summer also probably near or above average temperatures, which correlates with the dry. And so I would lean here more than near, but we are talking about a broad area here. And the 2020s favor more dry years than wet years. Why? Again, because of our current average. So again, going to play the markets. My big suggestion to you is look at what actually fell, not the anomalies, because in ag world, it's always, we're 75% of average, or we're 125% of average. But if you're 80% of average, there's some exceptions. The farther west you go to the Rocky Mountains, the more it matters. But most of you, 80% of average is what the average was in 5 years ago. So 80% of average, you're still going to get one heck of a crop out of it because that's still quite a bit of rain. So it's just, my reminder, when you're playing with statistics and stuff, to always keep that in mind. If you ever want to contact me, here's my email address for you. It's just my first name at last name at ndsu.edu. I will say I try very hard to get to most of my emails within 72 hours, but like the last 3 weeks, I don't think I would have met that. But most of the time, I can. If you do have any questions, don't be afraid to ask me. So, Amber, I left you the 10 minutes that you want.
You did. I think you were spot on here, which we love. But Daryl, I have to say, I really appreciate, the dry flavor to it. I think that is my new favorite phrase for describing a summer. That is a fantastic description. I think everybody understands what that means and can feel it in their own bones. But let's start with some questions here. The first one that I have that came in reads, why do La Niñas typically last so much longer and El Niños are so much shorter and or quick?
The whole process really deals with the trade winds in many ways and pressure differences across the, especially the Western Pacific. So say that Southern Oscillation a lot of times deals with the difference in pressures between Australia and Tahiti. And so in turn, when you get that pressure difference goes up, the trade winds will blow. But to get an El Nino, you have to remember, if you know the world circulation patterns, and by coincidence, I'm talking about this in my weather class this past week. But between, all the heat from the planet is at the equators, it rises and then it moves north and then it sinks about 30 degrees north and south latitude. What's at 30 degrees north and south latitude? All of our deserts, because that's where the sinking air is. So then that sinking air at those latitudes then have to go back and replace the air at the equators, and it flows towards the equators. So in the northern hemisphere, which most of you only care about, unless we're talking southern crop seasons, is that wind then blows as the trade winds. And in the northern hemisphere, those trade winds are from the northeast. And so if you think a northeast wind from the eastern Pacific is flowing westward towards, say, the Western Pacific, Australia, Southeast Asia. So really the El Ninos are disrupting that flow. And it is really, really hard to disrupt the natural flow of Earth rotating, the Coriolis effect. It's really hard to go against the physics of what needs to happen. So in turn, that's why they're generally short-lived in the sense of 6 to 9 months, and then they go back the other way. And it also then explains why La Ninas, the cold phase, can last for 2 or 3 years, because then it's really going with the physics, what's really is trying to happen.
Interesting enough. That's fascinating. The next question here, I reads right to what we were just talking about here with soil temps, and it reads, how long do you expect until temps start to level out and increase the soil temps warm up? Get your crystal ball out here.
I think it's going to take at least 2 more weeks. And again, it's always the obvious here. The farther south you're listening from, some areas are already close to 50. But really, if you get north of, say, Interstate 80, kind of split there, I think it's going to take at least a couple more weeks to get the temperatures consistently at 50 degrees. And if you're a crazy person like me and living in North Dakota or northern Minnesota, that area, it probably might not be consistent till May 5th to the 10th, even to get there. It's a very slow process. The nice thing is, once you get soil temperature to a certain point, it's really, you build up enough heat energy in the soil, especially if they're a little bit wet, that in turn they maintain their heat pretty well. And so if you had a cold snap, they wouldn't drop very much. So that's the really good news of soil temperatures. Once you get to that point you want them to be, that usually they don't drop very quickly. You usually have to wait till fall to get them back down.
So definitely have to have a little patience here in those upper Midwest states as they come around.
Right. And this year, there's some signs of spring being a little bit ahead of schedule. Some signs it's a little bit behind. I would say it's been kind of average in a way. It's just after you come back off of a winter like we had, where it was average or it wasn't a lot of snowfall, people always think, oh, I'm going to go out in the field early this year. I'm going to get out in the field early. And it's really weird. A lot of opener winters like this, you don't end up in the fields early because Mother Nature makes up for it in the spring a little bit. And it's not been a terrible spring in most areas, but it's still just, that's why I said it's just, I don't think spring's coming quite as fast as most people wanted or thought. And that's why I put it in my tag. But, it's going to come. And I think, there are some signs out there that will get, the average highs and lows just increase. So a cool day 2 weeks from now is not the same as now, but we'll get there. I think most areas will get there by the end of the month.
Okay, that's good to know. And I mean, when we see that the ground is bare, I feel like we always start to get itching to get into those fields, even if it doesn't necessarily mean or make the most sense at the moment. But next question here reads, will the recent rain in the Midwest be enough to help the already drier soil conditions and likely drier than average summer coming?
I think in most areas I'd be concerned. There are some indications out there that we will see a more widespread rain event at the very tail of this month into early May. And it would be severe weather. And if you're going to have severe weather, this is the time of the year to have it because you're not going to get much crop damage because not much has, popped out of the soil yet. But, that's 2 weeks from now. And when do we not, there are years we don't, but most years we have severe weather and we get the rain. So it's not like I'm a magician coming out if it happens. Like, wow, Darrell, you're so smart as a meteorologist. Most people listening would understand, oh, that's, just spring. But I only say it as if that would bring widespread, even 1, 2 inches of rain, then we're adding even more. But I really think, especially close to the Mississippi River and westward, is the area that statistically and what's happening right now has that drier flavor to it that, any moisture we get now would be beneficial for the future because you can store it a little bit. But I understand the question. And to be honest, I understand a little bit nervousness in that right now.
It'll be an interesting to see what happens here in the next few weeks as we go forward with it all. And speaking of severe extreme weather, this question reads, why is it that extreme weather has begun earlier this year, like the tornadoes that recently happened?
I would say it's not earlier than normal. You have to wear the worst tornado disaster in the United States occurred in mid-March in the 1920s. So it's really, a lot of things you read online, as politely as I can say this, is clickbait. And if they tell you that this is unusual and unprecedented, which they do almost every storm, if you know your history, it's really not. And so I would say that it really, from my perspective, knowing the past quite well, I didn't find it unusual at all. If we had a horrid tornado outbreak in February, I'll give it to you. But this year, I would really argue strongly that it's been pretty close, to average. If anything, we had the severe weather mainly where most people watching from south of us was pretty typical fashion. In a way, I'm surprised now that we're getting well into April, where's the next one? Like why, I lean a little bit the other way, but that's why, if we get this towards the end of the month, early May, that'd be pretty typical for us to get it. So I don't know if that really answers the question. I just personally don't find it unusual.
Well, and that's why we have you answering the questions because you're going to give us your thoughts and your opinions, and those are the ones that are more than likely, like you said, not the clickbait that you would be reading online. So we appreciate the candor there. But as we get towards the end of our time here today, Darrell, what are those 1 or 2 key takeaways that you want producers to be thinking about or actively doing after today's discussion?
Well, I would say be patient with the spring. I mean, it's always, I grew up in rural southern Minnesota. It's always the weather in the spring. Everyone wants perfection. And there is the one year we all remember that it was perfect. But that's always the exception, not the rule. But I think things will go according to plan. It's really, every time I say this, I tag it with I hope I'm wrong because I truly hope I'm wrong. Again, it just looks drier than average. Let's hope we get the timely rains, and people send me stuff. I know other people go, oh, the summer is going to be like really super dry, but again, some of that's clickbait because none of us really knows. I just think it's going to be dry enough that it will lower yields and not be 2012 all over again. That type of thing, or 1988. Could it be? Certainly. There are a lot of, but it just doesn't look that way to me to be that bad. But, if we still get timely rains, look at last year. Many of you were probably below average, and I bet you a lot of folks had pretty good yields, last year. And there's a lot of chaos in the markets right now. And I'm not going to go into politics right now at all. It's not my thing to do. But there's a lot of uncertainties out there. And so, the weather is the one that we always have the uncertainty to. But that is going to play a factor in a lot of things going on this year in the ag community as well. And everyone listening already knows that.
Well, Darrell, I appreciate not only your time here today, but also all the insight and information you bring because it truly helps explain why certain things are happening in our weather, and rather than just being told it's going to be drier and just got to deal with it. It's the why. This is the how and the why that really makes a difference when analyzing and thinking about critically what's happening in our area. So thank you so much for your time here this afternoon.
Oh, you're very welcome. And again, look at rainfall totals, not necessarily anomalies.
That's, I think, a great last message to leave us on. And with all that being said, I appreciate the time from those who are listening and watching live or after the fact. It's always appreciated that you're joining us here on the Dairy Signal. But for now, have a great rest of your day, and we'll see you here tomorrow. Bye now.